Hey guys, thought you might be interested in seeing my newest addition to the test equipment and so forth. This is a electronic dummy load. Got it from AliExpress. It's good for up to 200 volts or 20 amps apparently, and not exceeding 180 watt total load. So this is going to be very handy. I've always wanted one. I had half-assed built one, but I figured, well, this was only about what, $50 odd, and so if I was to put in 5 hours of time trying to refine a home-built one, it still might only have half the functionality, but you know, it's just easier. So it came with this, a 18650 battery holder, which interestingly on the sale on the listing it had wires attached on there one, but that's fine. I can attach wires to that, not a problem. It also comes with a travel adapter, a set of leads with lots of leads. Let's cut that open and see what's all bundled up there. Aha, so we have USB 2 alligator clip. That will be handy as well, and just a couple of individual alligator clips with a lead on, along with a adapter for powering the device, and this is 9 volt 2 amp capable. Not that this thing's going to draw 2 amps, but wow, be interesting to throw this on the oscilloscope and just see how clean the power coming out of it is. I can't think this meets any particular spec that would be suitable in New Zealand. Interestingly, it's come with 2 of the same travel adapters and not one for this particular country. So I could do the old nasty on that and just get some pliers and bend those until they're at a, what are they, 45-degree angle. I don't think I'd use this long term. I'd just hook it up to my bench supply when I decided to use it. And the unit itself, it's fairly basic. It's got a LCD at the bottom there, a couple of knobs for adjustments, a button, and then a range of inputs for testing. So we've got USB-C, micro USB, USB-A, I think that is, another USB there, full size. Or was that USB-B and that's USB-A? Can't remember. A little jack, and some screw terminals, so you can just wire anything directly to it and load it up. And a large heatsink. They've repurposed what looks like a CPU heatsink there, so that's kind of cool. I mean, unless they made their own, it's possible. I mean, it's got an offset mounting for the fan there. It doesn't sit square on the heatsink, so maybe they did spin their own cooling design there. But one thing I noticed when I got this, and you probably still can see it a bit, is the big bow in the PCB from the posts being tightened, and it was really quite bad. You can see it lifted at the left edge there, and it's not too bad on that side now, but I've backed the tension off on the screws. What it has is a brace across the bottom here, but I don't think it's definitely not sufficient enough. They could have made this out of a thicker PCB as well, given the loading they're putting on it, but I'm not really a fan of bending PCBs that much, although the only thing that's going to be affected really would be the fan power and the DC input to power this whole thing. But certainly there's a lot of flex available, so I've backed them off to a point that's holding the heatsink against the power transistor in there, and it's also got some thermal compound in there as well. So we'll keep an eye on the temps and we'll just see if that's enough, and if not I may have to look at a custom reinforcement for ongoing use, because I wouldn't want this thing to fold in half. But it's interesting looking at the bracket there. You can see there's the cutout in the center there. There's quite a bit cut out on the top edge there. And if I show you what the picture of the one that they supposedly advertising there, and here's the listing, and if we scroll to there, check that out. That's a pretty solid looking bracket versus what's on the one they've shipped. So I'm wondering if I've got old stock and they've actually re-engineered the bracket to be stronger, having some known issues there. But just interesting thing to note. So this does have timed discharging, so it will calculate battery capacity, which I'm also going to enjoy having. I've got some nice old batteries that I'd like to see if they're any good still. And there's the specs on it. 6 to 12 volt supply rail, can be powered through micro USB as well, so that's handy. I'm running out of sockets for wall warts anyway. 0 to 200 volts measurement ability, 0 to 20 amp current, with a resolution of 0.05 of each. Will measure up to 999 watt hours, amp hours, amp hours, and what do we got? 99,999 watt hours, and about 3,000 watts of range of measurement. It also gives temperature, which is handy. We'll be able to find out if the heatsink is sitting tight enough or if we have to look into that. In theory we won't see the fan on unless the current is over half an amp or the temperature exceeds 45 Celsius. I'm going to power it from USB, and that raises an interesting thought, because that fan on the top looks like a standard 12 volt fan, and if we're only feeding it 6 to 9 volts, it's not really going to spin at full speed, is it? If it needs to spin at full speed to maintain a good temperature. Just something I thought was interesting. So let's connect it up. We're just powering it off USB at the moment. How do we select English? Apparently it does do English. Okay, it doesn't specifically say in the instructions, but if I push the button once, we get the English version of the display. Now it says to press the button, single press, and it can enter other setup modes. So that's just a different display layout. There's another one. That's showing a resistance down here. That's interesting. We can have backlight on or off, but I don't quite know actually how to change that yet, because they're pots, they're not buttons, so it defaults back to Chinese. Maybe I hold it down. Ah, okay, so it's got a timer for the backlight to go off, so backlight off. Oh, it didn't come back on. holding it down, holding it down. Is it possible to ever get it turned back on? I don't think so. Let's turn it off. Try again. Uh-oh. It doesn't default to backlight on. How do we get our backlight back on? Ah, double tap. Uh-oh. So you got to double tap to increase, which means... But if I hold it down... Oh, it goes up again. Ah, okay. That's okay, so it goes... now we're on again. Wow, what a system to work out. Okay, so we can do greater than 300 volt. Well, it's interesting because it's only rated to 200 volt according to the spec. So, yeah, I think I'll just leave them alone for now. I'm not going to be jamming that much into it. Right, so I've got my supply hooked up. It's positive on the top, negative on the bottom. And I'm just going to set it to 12 volts. And it can supply a maximum of 3 amps. So, quite a bit of glare on that LCD, isn't it? Maybe I can prop it up with something for you. A roll of solder wick or two. The knobs are fully anti-clockwise. I'll connect the power. And now it's come up with voltage 11.8. So I'll just tweak that because we'll need to allow for the loss over the cable, I suppose. There we go, exactly 12 volts. It says 12.1. Actually, we'll be a bit more scientific and check it with the multimeter. 12.04 according to the meter. Right, now the lower knob is the coarse adjustment, so in theory if I start turning that, it won't do anything. Okay, maybe we have to be in a different mode. Here we go. No. Maybe both knobs. Oh, there we go. Okay, did I read that wrong? Apparently the top one is fine adjustment and the bottom one is coarse adjustment. 0.32. Maybe the bottom one can't be on 0. No, that's working. It seems it doesn't kick off until you go up to half an amp. That's funny. We'll turn that back down to 0 and then we'll come back up again on the fine adjustment. There, it didn't happen until quite a way on. So that should be half an amp, and indeed my power supply is saying 510 milliamps, so that's fairly accurate. See, the voltage has dropped, to be expected, across the wires feeding it. But I find that interesting that it doesn't kick on right away. I haven't read anything yet that suggests that, but if we wind up the coarse adjustment alone, it's really not kicking in. I think they've labelled them backwards. So I'm getting a lot finer adjustment with the bottom one. I'm going to say the top one is the coarse adjustment. The bottom one is the fine adjustment. Yeah. And if we turn the top one, well, the top one's on 0, so that's okay. So can I get up to 3 amps? There we go, 3 amps using the coarse adjustment. I'll back off the fine adjustment. And it looks like it's measuring at 22 Celsius at the moment. So that's 36 watts. Volts times amps. Well, 33. 11 volts at the terminals. It's 12 on my PSU, but yeah, you know, there you go. So there, that's just a quick look at how this is operating. If I hit the button, what other info do we get? We've got that layout there. Oh, it's calculating the wattage up there, so 34 watts at the moment for us. Our amp hour rating, our watt hour rating. I just noticed on the PCB it is marked coarse and fine at the bottom. I was going off the provided documentation, which seems to be in reverse. Well, the fan's really going for only a 6 volt input. Well, sorry, a 5 volt input. It's drawing half an amp, half to 0.6 of an amp through the supply to the board. And it's maintaining about 25 Celsius. So, not too shabby at all. I just touched the bottom of the PCB under the main MOSFET, and it's cool. Cool to touch. So I'm now maxed out at 28.3 volts. Skip back to the start there. Here we go. And what is 180 watts at 28 volts? 6 amps. If we crank this thing up, we're not going to achieve 6 amps. My supply can only do 3, so we should be able to get to about 84 watts. Let's see what happens. There's still quite a rotation. Like before that kicks in, here's the mark on the knob, right? It's about 7 o'clock, and we come right around to 11 o'clock before, you know, that much swing before it even starts to register. That's really fine adjustment there. I wonder, yeah, we'll back it right off to 0 and see if it actually adjusts down to 0 once the course is selected. But the course kicks in pretty quickly. So there we go, we're at 3 amps already. And calculated at 83 watts. 80 fluctuating, give or take. But oh, I just exceeded my supply there. 32 Celsius at the moment, 82 watts running through there. Well, I guess we can see it works. 35 Celsius. Now the run time's not accurate because it's carried on from before, but about a minute so far, I guess. Well, this is going to be great for testing batteries. I'm going to have to get, let's grab a couple of 18650s here. And I have no idea what they're rated at. It's not printed on the label. I got them cheap, so it's not a good start. Really should make a case to mount this in, I think. I haven't printed anything for a while. Maybe that can be my next mission. Okay, let's see if the fine adjustment works right down to 0. It seems to be. So with a decent amount of current running through it, you can actually use the adjustment right back down to 0, unlike its starting point of a fair way in. Right, I just had a cunning idea. Let's test the power supply that this thing comes with. So I've got it plugged in and it's reading 9.15 volts. Now this should be capable of supplying 2 amps. And what I'll do, I measured through the DC jack and these binding posts, and they're all joined together. They're all paralleled up as a common input, so you can dump multiple loads on at once, but you want to be careful doing that. And you wouldn't want to exceed any voltage of one to the other, for example. So I'm going to stick the scope onto across the input so that we can monitor how well it regulates at maximum load. 9.1 volts, and I'll get you a shot of the scope. There we go. Now let's start juicing it up a bit. Okay, we're at 1 amp and it's looking fairly stable. We're at 2 volts per division, even though the the capture software disagrees a little. So we're sitting at 2, 4, 6, 8, 8.2. It's a little bit low. It says 8.7 on the LCD here. There we go. Must need to calibrate the scope. Okay, let's keep going up there. So it should be 9 volts out, and at 1 amp it's already down to 8.5, or 1.2 amps there. There we go, 8.6. So I'm not sure it's going to be able to do 9 volts at 2 amps. But anyway, we'll keep winding the wick up. We head up to 1.7 amps, we're already down to 8.4. And as we approach 2 amps, we're at 8.3. So it's definitely not meeting spec. It should be able to do 9 volts at 2 amps according to the sticker. Well, how much noise have we got? The line looks fairly solid. So let's keep winding this up and see at what point it just falls on its face. 2.2, 2.4, 2.6, we're down to 7.5 volts. 2.8, 5.8 volts. There's a bit of ripple starting to show there. 3 amps, 4.2 volts, so that's struggling. I don't think I'll attempt to blow this up. Must have a shut-off point though. Oh, 1.2 volts at 3.4, yeah, we've lost it. So we'll wind that back down. Let's go back down to 0. Now, at what level does it manage to stop regulating 9 volts? Half an amp, 9 volts at half an amp. 1 amp, 8.7. Yeah, not really up to the task. But this thing only draws half an amp when it's running with the fan on, according to my USB current meter, which is feeding it. And at half an amp we get our 9 volts. So I'm sure this would be perfectly adequate if all it was doing is running this device. But I wouldn't rely on it for anything else if you wanted to get some power out of it. Now I've got a 18650 cell in the holster, and let's run a discharge. I think we'll do an amp. I think this is supposed to be 1600 milliamp hour rated, but as I say, I can't remember, really can't remember. So we need to reset all the timers on this to 0, all data, press the key for a long time. So that was about 3 seconds. Now we shall increase the current and see what sort of runtime we get out of this. Now I don't know if you have to put this in a particular mode for discharge. I think you can set the point at which it will auto cut off. I haven't really read that far into it. So what do we say here? There's capacity data, electric quantity data, time data, timer, auto timer and discharge alert, setup window for high and low voltage, background light, and without load, click key 7 times for current data reset. So that's a calibration of some sort apparently. Okay, so I think we just turn the current up and then let it go, and when it's dead, and we measure off the read off the time it took and the amp hour capacity. So here we go. Ooh. Going to 1 amp. Pretty accurate. Might turn it down a tad and use the fine adjustment to get it bang on. There we go. Right, well, I left it running and it's been going for what have we got, 1 hour 12 minutes, and it's come up with 1.78 amp hour. That's a better angle. So yeah, I had a feeling it was probably a 1600 milliamp hour rated battery, but she's died off at 1.78. That's been running at 1.5 amp draw for that long. I actually cancelled the test and gave it a full charge and ran it again. So yeah, if I crank up the power on it, ooh, yeah, so I had 1.5 amps, and 2.8 volts is considered full discharge on one of these cells. So yeah, she started to drop off pretty rapidly. Now it's been sitting for a bit, it's got a little bit more in it, but there it goes. It'll start. So yeah, that worked really well. So there's a quick review of this generic dummy load. Hopefully you found it useful. There's really no point going into all of the button functions. It just seems to be how to reset the totals, and it sort of talked about setting cutoff points, but I think it's similar to the backlight procedure. You just got to hold the button down and cross your fingers and point your tongue at the right angle, and probably figure it out. So yeah, do I recommend it? I don't know. It seems to do its job. It seems to be accurate in its measurements. Definitely not sponsored or anything. It's just I needed one. There it is. You may benefit from one as well. So thanks for watching, and thanks everyone who's subscribed. We're over 6,000 subs now, which is pretty impressive for a kind of a niche market of video. Anyway, take care. See you next time.